let's set and check our temperatures for the films we are using. If you have threaded the machine cold, turn on the heat controls now and set them for the desired temperatures. From a cold start, the machine will be ready in 12 to 15 minutes. While the machine is heating up, open both sets of rollers, set the speed control to around 10%, and engage the forward drive. This allows the laminating rollers to turn and get evenly heated while the machine is warming up. Evenly heated rollers contribute to the quality of the lamination by eliminating the chance of imperfections in the finished lamination caused by cold spots on the laminating rollers. Position the feed guides to help you feed your images squarely into the nip. You will get the best results by centering items in the web. Check and balance the supply roll tension on both mandrels. Start by loosening both knobs until there is no pressure on the springs. Tighten each knob until it begins to press on its springs. For initial adjustment, put 3 to 4 half turns of adjustment on each knob. Once the machine has come to temperature, you are ready to make final adjustments of the supply roll tension. With the heat on, rollers closed, push the green forward drive button and watch the film as it passes over the heat shoes. You will probably see some waviness or wrinkling in the leading edge of both shoes. The leading edge would be the top of the top heat shoe and the bottom of the bottom heat shoe, the edges that the webs of film first come into contact with. If the waviness or wrinkling, sometimes called fingering, extends from the leading edge into the laminating rollers, the supply roll tension needs to be increased. Remember, when adjusting supply roll tension, to adjust both ends of the supply roll mandrel evenly to keep the tension relatively the same for both the bottom and top supply rolls. If the laminate coming out of the back of the machine is curling upward, there may be too much tension on the top mandrel or not enough on the bottom. Adjust your tension knobs accordingly to get the lamination to run as flat as possible. A little bit of waviness or wrinkling on the leading edge is acceptable as long as it does not extend into the nip and onto the laminated web. Examine the film going out of the back of the machine and adjust the tension to eliminate remaining wrinkles or bubbles. Also, when running any thickness of film over 1.5 mil, be sure to run the cooling fans to help alleviate heat rippling and wrinkling. As mentioned before, for best results, the film should be tight and flat between the laminating and pull rollers. If it gets out of the back of the machine while it is still at or above melt temperature, heat wrinkles and distortion can occur. Once you have run off enough film to alleviate wrinkling and get the lamination running relatively flat, you are ready to run a couple of samples of your work through the laminator. This will also help you get comfortable feeding items into the nip. Take your image and lie it flat on the feed tray, positioned against or very close to your feed guides and square to the nip. Make sure it has been made as flat as possible to avoid wrinkling or fold over when you push it into the nip. Note: the laminator has an anti-curl strip right before the nip on the feed tray to help you flatten out slight curls and imperfections. Now, with the temperature at its predetermined setting, the rollers down and locked, and the fans on, press the green drive button to on and set the speed dial at between 10 and 15%. Allow approximately 4 to 5 inches of laminate to pass through the nip to clear any wrinkles, then gently push your image into the nip until you feel the rolls grasp the piece and start pulling it through the laminator. At the moment you feel the machine take hold of the piece, stop pushing forward and use a slight backwards fanning and flattening motion to help ensure the piece lies flat and wrinkle-free as it is pulled through the laminator. Once the piece clears the nip, it will proceed over the cooling fans, through the pull rollers, and out the back of the machine in a beautifully laminated, fully encapsulated state. Once the image has cleared the pull rollers by 2 to 3 inches, you can now shut the drive off and trim your piece. As mentioned before, running some practice prints is recommended not only to get a feel for the technique, but also to be sure the images have a good laminating bond. While most offset printed materials laminate very easily, with a tremendous bond, some inks and papers used in inkjet printing may not adhere quite as well. To determine how well your laminated piece has adhered, we will perform what is known as the X test. Using a utility knife, score the top of the laminated piece in an X pattern. Lift the edge and pull back. If you lift ink and paper fibers as you pull back, you have a good bond. If you pull back the laminate with no resistance or without lifting ink or fibers, the lamination is not good. More heat and/or a slower laminating speed may be required to get an acceptable bond. If you still cannot get an acceptable bond after adjusting the speed and heat several times, give us a call. We will evaluate your combination of film, speed settings, heat settings, inks, paper, etc., and make recommendations. With some practice, this video and your owner-operator's manual as guides, you are now ready to begin production work. Most thermal laminating film consists of two layers, a base layer of polyester and an adhesive layer of polyethylene. The polyester layer, the shiny side of the film, is the harder outer surface of the film and does not melt at laminating temperatures. It provides rigidity and protection for your laminated items. The greater the polyester content, the higher the level of protection, rigidity, and luster. The polyethylene layer, the dull side of the film, melts at laminating temperatures and bonds the film onto the subject material under the pressure of the laminating rollers. As the X test described earlier demonstrates, this adhesive is melted, then pressed into the paper and inks, making one integrated piece consisting of paper, ink, and laminating film. The proportion of polyester to polyethylene in the film is usually described as a ratio. For example, a number 1:2 film would be a 3 mil film with 1 mil of polyester and 2 mils of polyethylene. The first number refers to the base layer, the second to the adhesive layer. A mil is equal to 1/1000th of an inch. Since polyester is the more costly of the polymers, or plastics, used in these copolymer films, a number 3:2 film will generally cost a little more than a 2:3 film, although both are called 5 mil. Also, the number 3:2 film will seem a little thicker than the number 2:3 because it is slightly stiffer. Laminating films are available in many different base-to-adhesive combinations. In the United States laminating trade, the generally accepted practice is to describe two-sided lamination, or encapsulation, by the thickness of one layer of film. For example, 3 mil lamination should refer to lamination with 2 layers of 3 mil film. If you are buying or selling laminating film or laminating services, please make sure everyone who needs to know understands the film descriptions being used. We encourage you to experiment with different films. There are many finishes available, such as glossy, the most popular, satin, matte, textured, marbleized, black films, films with protective liners, films with adhesive for window graphics or mounting, and more. The cost of thermal films compared to the pressure-sensitive films is so low that you can afford the luxury of experimenting without breaking the bank. We suggest you try various combinations of film. For example, use a glossy film on the top mandrel with a matte or satin on the bottom mandrel. This allows you to offer different finishes without changing the setup. You can run an image upside down to get a matte or satin finish on the front of your piece without